All right, so a couple things before we kind of get going. Sorry for the crazy week last week. Moving forward, if we're not in class, I try to use Canvas's announcements to get out any information to you guys if I can't tell you in class. So hopefully the rest of the semester, everything will be back to normal. With a caveat, a little bit of this week. I still have office hours tomorrow, and I had them yesterday. They're just going to be virtual this week. Also, if you want to meet, I should be pretty available on Friday to meet. Just send me an email. We can kind of work out a time to meet virtually. I'll be on campus just for classes this week on Tuesday, Thursday. But then next week, I kind of should be back to kind of my normal office hours in person, as well as kind of being in class every single time. So a couple things I want to mention before we dive into material. One, on the Module 4 reading that was due last night, so I went back and I gave everybody credit for a particular question. I'll kind of mention why in part of what we talk about during today's lecture. And I think it was question 3. So if you've emailed me about that and I didn't get back to you, I'm going to answer it today in class. Other than that, I'll have assumed that you watched those 2 videos I posted for replacement like lectures from last week. Those are on the YouTube playlist. It's everything that we would have done in class, including all of the work that I did like on a dot cam. Moving forward, we're going to be back to like, if you want to get what I'm doing up here in class, you need to be in class. So these recordings are not meant to be perfect substitutes. They're going to have everything we do except for kind of what I'm doing up here in the bite. Someone email me, could you please include that? Well, at the beginning of the semester, I kind of laid out, I want to create some incentives to be here in class because I know that it's easier to be passive if you're just relying on those videos. They're not meant to be a perfect substitute, with the exception of last week when we didn't actually have class. Okay. So hopefully, like I said, no more issues moving forward. I also put up an announcement. This is like back in the second week, but I just wanted to point it out again. So this extra tutoring sessions, I've had some people reach out, and those CL sessions are good things to review for like the material that week, to look at those practice problems, see them work through. But if you're looking for additional help, there's free economic tutoring sessions over in Wiley. So that's where my office is at, up on the 3rd floor. Is it 329? Where is it at? Nope. Yeah, 329. I remembered it. Okay. So there's slightly different times, but primarily like 6 to 9, 6 to 8, 7 to 9 on Tuesday, Wednesday, Thursday nights. So I mentioned this before that they're not specific to this class or section. 252 students might be there asking questions, et cetera, 370 students. However, that Wednesday night session from 7 to 9, one of the CL leaders who's worked for me before and is working for me this semester, who I think is does a particularly good job at answering questions and has a really good understanding of the material. She is actually going to be one of the individuals that is there on Wednesday nights from 7 to 9. So I can definitely vouch for her. Who's there at the other times, it kind of varies. Once again, they're not specific to this course or section. She will know everything since she's also a CL leader about this course and specific section. So those Wednesday night tutoring sessions might be a really, really advantageous thing to go to if you're looking for additional help. Okay. Other than that, I don't think there's anything else I want to mention off the top. We'll pick up on kind of module 4 here today. Now, this week after Thursday's class, you'll see the module 4 quiz, but you won't see the next module reading. Okay. So why? Because next week we're not going to be covering a new module. Next week we already have the first exam, right? So it's 4 modules and an exam, 4 modules exam, 4 modules final, right? So I put up yesterday, and I'll get it posted up on the homepage, if not later this afternoon, tomorrow early in the day, the practice exam, or at least the first practice exam for next Thursday's midterm. I'll probably get up another one that has another set of questions that would be helpful as you're studying, but I wanted to get this up there as early as possible. So if you're thinking about starting to study for that exam, these will be questions that look pretty similar to the types of questions you'll see. I think there's only 20 in this. I think there are 20 questions, on this practice exam. There'll be 25 on the midterm. which is why I'm going to get another set of questions, which looks like another practice exam up there. Hopefully by the end of the day tomorrow, if not before we start class on Thursday for sure. So you'll have a whole week with that second practice exam as well. Okay. So start studying early. Next Thursday is the midterm, which means Tuesday, instead of just not having class, which I guess technically I could do, I will be here, and it's not meant for me. This is completely meant for you to come to next Tuesday's class. After looking at these practice exam questions, looking over old quiz questions, I want you to ask me questions during that time. That is how I can make it the most effective for you. Otherwise, I can pick and choose questions I think might be beneficial. But, you know, if you ask me specific questions, don't be shy, don't be quiet during that class. I want to be answering the questions that you guys have. So come to that class next Tuesday with questions ready to go. We can kind of go through as many as possible in that time frame to kind of get you prepared for that exam on Thursday. Okay? It's kind of a bit of a roadmap. Any questions from me before we start Module 4 material? Yeah. So, are the exams cumulative? No, but I said they are close to cumulative, comprehensive, right? So the first exam, I mean, we don't really have to worry about this, right? Because it's just the first 4 modules. The second exam will be the next 4 modules. It's just everything in this class really builds on itself. So they're comprehensive in the sense that, like, we still need to know what the demand and supply curve are, but I'm not going to ask you the types of questions that I was asking you on, like, the Module 3 quiz. Yep. Any other questions before we dive into Module 4 here? Okay. All right. So let's go. You guys hear me okay in the back? Good. All right. So we'll come down here and we'll look at Module 4. So Module 4 is all about elasticities, right? So the one that we're really only going to talk about today and we're going to focus on is the price elasticity of demand, okay? So anytime we're talking about an elasticity, another word for elasticity, synonymous with that, you can think of as how responsive is something. So elasticity is how responsive something is. So we're talking about the price elasticity of demand. That first word is always going to be what is changing. So if the price changes, how elastic or responsive is demand, right? Or how much people are buying, okay? So in Module 3, we said that the demand curve is a combination of a bunch of different prices, and then at those different prices, how much are people willing to buy, or what is the quantity demanded? So when we're measuring the price elasticity of demand, we're measuring the elasticity of demand at different points on that demand curve. So we want to know how responsive is quantity demanded to changes in the price of that good, okay? So the way that we're going to measure this is going to be not just in the number of units, right? So the problem is, if I want to look at, like, if Starbucks increases, you know, their price for a coffee by $1, how many more cups do people buy? But if I change the price of a gallon of gas by $1, how many more gallons of gas? Well, I've now got different units. So one way we can compare across goods about, okay, is this product more responsive to price changes than this other product, is we want a unitless measure. So we're going to look at percentage changes in price and percentage changes in the quantity demanded, okay? So our price elasticity of demand will be the percentage change in the quantity demanded divided by our percentage change in price. By using percentages, we're getting rid of our units, right? And we can kind of compare across different goods. So before we get going here too much, I also, hopefully this will set us up for things we're going to talk about in the future and kind of hammer home some of the points about this price elasticity of demand. So we're going to talk about different types of elasticity on Thursday. So right now, we were saying we wanted to know about the price elasticity of demand, okay? So in general, the way that I would think about the price elasticity of demand is how, we said elasticity is how responsive is whatever that second word is. So the elasticity of blank, this could be elasticity of supply, elasticity of demand. How responsive is that second word? In our example today, how responsive is demand to changes in whatever word comes first. That's the, not quite the most technical way of saying it, right? If it's price elasticity of demand, how responsive is demand to changes in price? Price elasticity of supply, how responsive is supply to changes in price? Income elasticity of demand, how responsive is demand to changes in income, right? So we'll start talking about different elasticities. And this is just kind of in English, how you would kind of maybe restate what the price elasticity of demand is. It's how responsive is demand, that word that comes second, to changes in price, the word that comes first, okay? Now, when we're looking at this, if I have my elasticity of demand, if I saw, why are we looking at percentages, right? So if I were to look at, say, the price of a gallon of gas, and it went from $2 to $3, that's a pretty large percent change in price. But it was a $1 increase. But if I don't use percentages, if I look at that same $1 increase in the price of a car, going from $40,000 to $40,001, that is a very small percent change in price. It's still a dollar increase, but it's such a different percentage change that it's going to elicit different behaviors from the consumer. You change the price of a gallon of gas by $1, people might not buy as much, right? We said what's true about the demand curve. As we increase the price, people will buy less, right? So if I'm thinking about that percentage change in my quantity demanded over my percentage change in price, if this is how we calculate the price elasticity of demand, anytime the price goes up, we have a positive change, we know consumers are going to buy. So we had our demand curve. So as that price goes up, people are going to buy less, or the price goes down, people are going to buy more, right? So we're always going to have a different sign. So if I calculate the elasticity of demand like this, it would always be what? Every time the price goes up, if people buy less, negative over a positive is a negative. If price goes down, people will buy more. Positive over a negative is negative. So this is why I gave everybody credit for question 3 on the module reading. We hadn't talked about it in class yet. You read carefully. You hopefully would have, you would have kind of continued. I think the way that the question was placed, it was before or was just after. You don't simply take the percentage change in the quantity over the percentage change in price. We actually have one more step. Oh, where is it? I'm going to skip ahead here, which is you take the absolute value, right? So we always know that this price elasticity of demand will be negative because we know that demand is downward sloping. We know about that relationship between price and quantity demanded. So in order to compare across these different goods, because larger negative values are actually less than, but that actually we'll end up seeing reflects that it's more or less, it gets a little more confusing. We'll just drop the negative sign. We know it's always going to be negative, so we're just going to talk about it in absolute terms, or we take the absolute value, okay? So we have this kind of elasticity of demand. We'll eventually just start taking the absolute value, and we don't care about that negative sign, okay? So how do we calculate it? Well, if I'm given percent changes, this should be relatively easy, right? Now, it's a little bit tricky. So I've got my percentage change in quantity demanded over the percentage change in price will give me that price elasticity of demand. So if I told you that, Netflix, increases their prices by 50%, and as a result, people, we see a 25% reduction in the number of accounts. Okay, I plug in my percentage change quantity demanded, negative 25, plug in my percentage change in price, 50. I kind of skipped ahead. We then would take the absolute value. We would have a price elasticity of demand of just 0.5, okay? So I don't know, I think that's relatively kind of easy to calculate this if we're given the percent changes, but let's think about what that's telling us, okay? So one reason why the price elasticity of demand initially can get a little tricky is when I'm thinking about my demand curve, how would I calculate my slope? It's the change in what? Change in Y, so change in price over change in quantity or my X axis. But I just said the price elasticity of demand is the percentage change in the quantity demanded over the percentage change in price. So slope and elasticity of demand are using similar things, but if I'm flipping the numerator and denominator, they're always going to be inversely related, right? So, well, I mean, I think by the end of today's class, hopefully we'll see why this is how we calculate it, why it's not the same as slope. But it can get a little bit tricky when we're thinking about slope and elasticity of demand because those two things get flipped, okay? Everybody with me so far on this? Okay. So I'm going to skip ahead a little bit and do things a little bit out of order of the slides, but I think it'll make sense. And then the slides will kind of have things kind of all summarized for you there. So if I've got my elasticity of demand here, excuse me, if I have an elasticity of demand that's greater than 1, okay? Remember, what this is trying to measure is how responsive people are to price changes. If I had a price elasticity of demand greater than 1, what does that mean? Well, if I rewrite this, and here I'm taking the absolute value so I can just kind of think about, I'm ignoring negative signs. If this fraction, right, which represents my price elasticity of demand is greater than 1, what would have to be true? Well, mathematically, if I multiply both sides by the percentage change in price, I'd be left with what? That percentage change in the quantity demanded, anything times 1 is itself, is less than the percentage change in price. Or if I think about what would make this fraction greater than 1, the only way that's possible is if the numerator is what? Greater than the denominator, which is, that's all I'm saying here. I'm just rearranging it mathematically. Or if I can just see that by, oh yeah, this fraction is greater than 1, the numerator has to be greater than my denominator. So what is this telling me? This is telling me that if I have an elasticity greater than 1, whatever the percentage change in price is, how much more are people buying? So if I had a percentage change of 10 in the price, the percentage change in how much they're buying or the quantity demanded is going to be greater than that. So people are responding in terms of percentages more than what the initial price change was or what the initial percentage change in the price was. So anytime I have price elasticity of demand greater than 1, people are responding by a percentage that's greater than the initial percentage change in the price. So they're being very responsive, or we would say they're being elastic. Okay? So anytime we've got the percentage change in the quantity demanded being greater than that percentage change in price, we would say that demand is elastic. Okay? Now, I think in the example that I had in the slides that we looked at with that Netflix, we ended up with an elasticity of 0.5. So if we had an price elasticity of demand that was less than 1, well, what is that saying? That's telling us that, well, if I just rewrite this, once again, if it helps you, you can cross multiply, or you can just look at this and say, oh, what's the only way this fraction is less than 1? If that percentage change in the quantity demanded is what relative to the percentage change in price? So if this fraction is less than 1, the numerator has to be smaller, right? So anytime there's a percentage change in the price and the amount that people buy, the percent they buy changes by something smaller than that, they're not being that responsive, right? The price might have changed by 200% and they bought 1% less. Well, they're not being very responsive. So anytime we have elasticities less than 1, we would say that demand is, or that consumers are, inelastic. They're not being very responsive. Okay? So the ranges of this elasticity measure tells us whether or not consumers are responsive or not. Tells us whether or not they are elastic, or if they're being very responsive, or inelastic, being unresponsive. Okay? Any questions on this idea before we keep moving? Now, I left out one possibility. What if I had an elasticity equal to 1? Well, what would have to be true there? Remember, the price elasticity of demand is this. So what's the only way this fraction is equal to 1? Is if my numerator and my denominator are the same value, right? We call this unit elastic demand. Doesn't happen very often in practice, but right, it is technically possible, right? There's that kind of this switch point where as soon as it's less than 1, we would say demand is inelastic. Greater than 1, it's elastic. 1, it's unit elastic. Okay? Any other questions here? Yeah. If it's what? Unit elastic? I mean, it literally just means that for every single percentage change in the price, consumers have the exact same percentage change in how much they buy, right? So it's unit by unit, like it's this exact unit by unit match in terms of every percentage change in the price is matched, right, by a percentage change in the quantity demanded. If it's elastic or inelastic, that's not necessarily the case, right? I could have 201. I could have 50 and what would make this greater? 50 and 75 or whatever it is. Yep. Yeah, so we can jump the gun a little bit. I was going to say that, but since you're asking, and I think it fits in here as well. So we have these 3 ranges I just mentioned, like elastic, inelastic, unit elastic. We actually have 2 extremes that I haven't mentioned, right? And this is where I can also kind of point out it gets confusing when we're thinking about slope and elasticity. So let's say I had a demand curve and it looked like this. Okay? So if I have and this kind of helps us thinking about the extremes, helps us think about the points in the middle as well. If I had a completely vertical demand curve, what's true about my slope here? So remember, how do I calculate slope? That's change in y over my change in x, right? So yeah, the change in price is going to be something. The change in quantity is 0. Anything over 0 is infinite. Now, technically, it's negative infinity, right? It's like this downward sloping demand curve. But yeah, if I have like this negative infinite slope, the steepest possible demand curve. So if I just think, before we even think about it, like the elasticity equations, if the price is changing and people keep buying the same amount, are they being responsive or unresponsive to that price change? If you keep buying the same amount, you're very unresponsive. You didn't change how much you bought at all. So if I'm very unresponsive, I'm going to be very inelastic, right? Elasticity was measuring how responsive I was. The larger the elasticity, the more responsive I was to a price change. We just said here, I'm not responding at all. In fact, we can think about that equation. No matter what the change in the price was, what was the corresponding percentage change in the quantity demanded? It was always 0. So my price elasticity of demand for a vertical demand curve would be 0. Notice they're kind of inverse. When the slope is really large, or I have a really steep demand curve, my elasticity is getting closer and closer to 0. So they're inversely related. They're related, but not directly, right? They're going in opposite directions. And so this was what we would kind of call perfectly, well, if they're not responding at all, that means they're being perfectly inelastic, okay? On the flip side, maybe we can guess, if this is perfectly inelastic, what do you imagine a perfectly elastic demand curve would look like? Not vertical, but horizontal, right? If I calculate the slope of a horizontal curve, I know you guys are freshmen, but what's the slope of a horizontal curve? 0. We've got to know this, right? And you can think about, well, why? Okay, because slope is change in y over the change in whatever's on my x. Okay, price is staying the same. 0 over anything is going to be 0. Okay, so perfectly not inelastic, but perfectly elastic demand will have a slope of 0. But if I think about how I calculate that price elasticity of demand, even if the price is not changing, people are buying more of this product. So any number or anything over 0 is going to be what? So if I divide by smaller and smaller numbers, I'm getting closer and closer to. So if I divide by 10 and then 9 and then 8 and then what's happening to the fraction? It's getting larger. So if I divide by smaller and smaller values, if it continues to get larger and larger and larger and larger, it's approaching infinity, right? So if I had a truly horizontal demand curve, we would say that, well, the price isn't changing at all and people are buying more. They're being very responsive. I mean, there's not even a price change to respond to, and they're responding. So we would say they're being very responsive or perfectly elastic. Once again, slope and elasticity end up being exact opposites. When the slope is closer to 0 or it's flatter, we get price elasticity of demand that are larger and larger or closer to infinity. Okay? Any questions on this? Like I said, I jumped the gun a little bit here, but it makes sense in what we're talking about. I can give you a couple examples. So before I do, I want to point out one more thing about this. Technically, because I'll get questions about this, if I had perfectly elastic demand for something, that means people are like very responsive to price changes. If they're going to buy more, even if I keep the price the same, will we ever see companies lower the price? No, right? Because if I lower the price here, I know they might still buy the same amount they were before, but if I've lowered the price, I'm just making less. So we know the price will always bottom out kind of wherever they're being perfectly elastic. If you ever increase the price, this is where it gets to be kind of weird. If I'm perfectly elastic, that means I'm responding a lot to price changes. If you change the price by an infinitesimally small amount, if I'm completely responsive, how much do I buy? You increase the price. If it's an infinite response, my quantity demanded will always go all the way to 0. So technically the demand curve is actually like, when it's perfectly elastic, is like this L, right? Like runs along the axis. Like people don't buy anything until we get to this one specific price, at which point people don't, we can't predict how much they're going to buy. Probably fewer examples of perfectly elastic goods. We'll talk more on Thursday about traits that make goods elastic. So what would be close to like a perfectly elastic product? Probably something like cereal, where there's like several brands really making the same thing. So if I change my price, I just completely stop buying your product and just buy another, right? So like it has to be something where there's almost perfect substitutes. That's the only way we could probably see like goods be perfectly elastic. Now there's probably more examples I can give you that are closer to perfectly inelastic. So like I always use, I think I've got, it's later on in the class, but if I have cancer, right? What do you think is true about my demand for cancer, say, like medications? Could they increase the price? How much am I going to buy? Same amount. I want to stay alive, right? So goods that people need to stay alive. I always use a dumb example. It's like being like completely unresponsive to price changes. It's something I need to stay alive is the best way to and there are products that get like very close to that, right? Which is why we don't like to see companies price gouge. So I think I've got a meme later on. Does Martin, I always get the last name wrong because I want to say the name of the kid from the Recess cartoon. Is it Skelly or Scarelli? Does anyone know what I'm talking about? This dude bought the rights to HIV medication. They called him Pharma Bro for a while. And he jacked the prices way, way up because he knew what? If I increase the price, people are going to keep buying the same amount if they don't want to get AIDS, right? I mean, if they want this HIV medication, they're going to pay whatever price I increase it to, right? So there are products that get pretty close to perfectly inelastic. Perfectly elastic, like I said, you would have to think about a category of goods probably won't be perfectly elastic, like cereal itself, like the overall category is not perfectly elastic. But a specific brand of cereal, if there's like, Honey Nut Cheerios, there's also Kroger's brand of Cheerios. There's also, General, whatever the different brand. If I'm looking at a specific brand, then I might see something look a lot more perfectly elastic. Does that make sense? Yeah. Any other questions before we keep moving here? Unit elastic. So I can't completely give you one because it's a concept that we probably aren't going to get into until next class. But it does bring up a good point. When I'm talking about elasticities, for right now, I'm kind of talking about like, it's almost like there's an elasticity of the demand curve, but it's really every point in the demand curve is going to have a different. So we'll touch on this at the end of class, and we'll definitely go over where that unit elastic point is at on the graph on Thursday. Any other questions before we keep moving? I know it feels like I'm punting and kicking the can down the road, but it'll make more sense once we talk about some other things. All right. So we already talked about this. What we haven't talked about is how do we actually calculate this using a graph and using actual prices and quantity demand. So in that earlier example, I just gave you what the percentage changes were, but how would I calculate what those percentage changes are from an actual demand curve? Okay. So if I go from 100 to 80, that is a reduction in price of 20%, right? Going from 100 to 80, reduction of 20, that's 20%. Okay? But if I go from 80 to 100, that's an increase, same change in price of 20, but starting at 80, my base is now smaller. That same change of 20 is going to be a 25% increase. So the problem is we're moving between 2 points on the demand curve, right? So this is where we start building up to answering the unit elastic question. If I'm looking at the demand curve, and I just gave you 2 points there, right? I said, what was it? Price is going from 100 to 80 or 80 to 100. It matters about where I start, but this demand curve, I want to come up with an elasticity measure for that portion, right? And I don't care if I start at 80 or I start at 100. If I move between 80 and 100, I should have the same elasticity measure for that demand curve on that portion of the demand curve, okay? So what do I do, right? What's the kind of solution? Because it clearly here, it matters about where I started. What we'll end up doing is using this midpoint method, which is I take that change, if I just think about the price for a second, I take the change in price, and I then divide it by the average of those two prices. That will give me my percentage change in price. Okay? So the midpoint method is using these two prices, look at what the change was, but then divide that by the average of those two values, and that will tell me kind of the average percentage change, no matter if I started at 80 or if I started at 100. Okay? And then we would do the same thing for quantity. If I want to find a percentage change in anything using the midpoint method, I'll take whatever the change is and divide it by the average of those two values. Okay? So I'm going to show you this, and then I think once we work through an example, I'll show you how I would probably work through it as opposed to just trying to enter all of this into my calculator at once. Because this is going to make, I got to make sure I'm getting my parentheses correct here. It's likely I'm going to screw one up. I don't know. It's a lot easier. So I'll walk through an example and show you how we can kind of simplify this. But really, all we're doing with this midpoint method is to find a percentage change. We're going to take whatever the change is and divide it by the average of those two values. It's just that when we're calculating elasticity of demand, we've got a percentage change in the quantity demanded. We've got a percentage change in price, so we need to do that twice. So, and then absolute value, we always just kind of ignore the negative sign at the end because we always know that price elasticity of demand is going to be negative. All right. Where are we at in time? So we've got what? 12:25. Oh, we're good. So, right. If we had an example where I told you, all right, we're going from a price of $6, and at that price, 15 units were being sold. When the price is lowered to 4, people buy 25 units. How responsive was demand to this price change? Well, I could use that equation that I had from the midpoint method. I want to find the percentage change in quantity over the percentage change in price. How do we find a percentage change? I said take the change and then divide it by the average of those two numbers. How do you find the average of two numbers? You would add them up and divide by 2, right? It's nothing crazy here. So I could plug all these values in and make sure I'm getting this entered in my calculator correctly, or I could break this down into steps, and I think it'd make it a little bit easier, right? So we had this example where we were starting out, the initial price was 6. They lowered the price to 4. As a result, people bought 15 before, now they're buying 25. So what we can really think about what we're doing is we're trying to find between these two prices, we know that the corresponding quantities were here. We're trying to find the price elasticity of demand for this portion of our demand curve. So I'm going to write this out, just kind of the easiest one. So I know that I want the percentage change in the quantity demanded over my percentage change in price. If it were me, I would try to kind of break this down into pieces. So how do I find the percentage change in the quantity demanded? That's just going to be my change in the quantity demanded. And then kind of make that a percentage, I'm going to divide by the average of that quantity demanded. Okay. So how do I find the change? I mean, I could write this out, but to me, it's easier to hopefully at this point, you know how to find the change in two numbers, right? What's the change in the quantity demanded here? It went from 15 to 25, so my change was 10. What's the average? Well, once again, these are somewhat easy numbers, but if I got a calculator, I can do this pretty quick. 25 plus 15 divided by 2, right? And find the average of two numbers. So 40 over 2. Wait, I might know what? Yeah. 40 over 2 would be 20. So I get this percentage change in the quantity demanded is what? 0.5. Okay. Any questions on this? So what would I do? I just found the percentage change in the quantity demanded. I would go ahead and I'd plug that in up here. How do I find the percentage change in price? Well, what's the percentage change in price? It's the change in price over my average price. No, yeah, that's right. So what's the change in price here? It was $2. What's the average price? Add these up. 10 divided by 2 is 5. So this is what? 0.4. Go ahead and plug that in. Now you'll notice if I break this down and do it in steps, these are percentage changes, but you're like, what? 0.5 and 0.4%. If you break it down in steps when you use the midpoint method, these are the percent changes, but in decimal form. So this was a 50% change in the quantity demanded, 40% change in the price. It doesn't matter once we take the ratio of the two. If we're using the decimal form, we don't have to convert them at all. We can just go ahead and plug them in. So 0.5 over 0.4, we get this elasticity of 1.25. Now, somewhere I left off negative signs, but that's because we know that ultimately we're just looking at the absolute value at the end. So if you want to drop it at the beginning or at the end, it doesn't really matter. But it helps you to kind of break it down this way, and then you have fewer numbers to plug in here. That can sometimes make it easier than just trying to plug everything in all in at once. You can do it this way. It's just you got to make sure you're getting your parentheses right. Okay. Yeah. Yeah, so why don't we calculate the way that we usually do? Because if I'm looking at the same demand curve, it matters where I start, right? But that portion of the demand curve is still the same portion of my demand curve. So I want to calculate this portion of the demand curve should always have the same elasticity measure. It shouldn't matter if I move from 6 to 4 or 4 to 6. It's the same portion of the demand curve. So this is why we're using that midpoint method. Now, in practice, what you would do when you have more fine equations is what can I do? Well, I can calculate it down to the infinitesimally. I'm not going to make you guys do that, but you would calculate at the infinitesimally small change in price. And so we don't have to worry about the midpoint method. We're using derivatives and things like that to do, be more accurate. Keeping things a little more simplistic for you guys, instead of worrying about taking derivatives, we're just going to use this midpoint method. Does that make sense? Any other questions on this before we keep moving here? Okay. And we get out of here at 25, right? Perfect, perfect, perfect. Okay. So I kind of already mentioned this, but here's like a summary of what we already talked about in terms of when it's elastic, inelastic, or unit elastic, what has to be true about this relationship between the percentage change in the quantity demand and the percentage change in price. Right? So we've already kind of reviewed this. We've actually also kind of talked about this idea that slope and elasticity are not the same thing. So we really have 5 different ranges. So a general rule of thumb, and also this is like goes to show my naiveness and inability to anticipate things outside of my own scope of being in a growing up and speaking my native language. So I use this term flatter and steeper. And I didn't think that this is actually maybe something that's not quite clear. But the idea is like when I say flatter, it's probably easier instead of thinking about graphically to think about it in terms of like physics. Flatness just means like no incline, right? Like this is flat, whereas if I'm walking up here, I'm talking about this is getting steeper. Same thing, we're looking at a graph, right? The steepness of a curve, we're just thinking about it's a sharper incline. So our general rule of thumb, we kind of already got at this with the perfectly elastic and inelastic examples I gave you. But if I have a completely flat horizontal demand curve, we said the slope was what? It's a horizontal curve. The slope is 0. What was our elasticity measure there, though? Well, we were saying even if the price doesn't change, quantity can. So we had the numerator being some positive value. The denominator was 0. Our elasticity was actually infinite. So they're inversely related. So as something gets flatter, we're going to get larger and larger elasticity measures. As that curve gets steeper and steeper, when it was completely vertical, the steepest you can get, our slope was actually infinite, but our elasticity measure, the price was changing, people kept buying the same amount, so we said our elasticity was 0. So the steeper our curve, the closer we're getting to the elasticity of 0 or inelastic, perfectly inelastic. The flatter the curve, the closer we're getting an elasticity measure to infinity or perfectly elastic. Okay, so we'll kind of think about these different categories. I'll go through them relatively quickly because we kind of already did this. But if I had, and I'll keep using the same percentage change in the price of 10. So if the price goes up by 10%, if I have perfectly inelastic demand, what's the corresponding percentage change in the quantity going to be? Perfectly inelastic, they buy the same amount. So that change in the quantity demand is 0. 0 over 10, 0 over 20, 0 over anything is going to be 0. So our elasticity for perfectly inelastic demand is 0. We said that the slope there would be infinite. So they're kind of the exact opposites. Right? Now, as we move away from that, so we still have a relatively steep demand curve. If we look at that same percentage change in price of 10, well, if it's not perfectly inelastic, so when it was perfectly inelastic, that percentage change in quantity was 0. Now when we change the price, people buy a little bit more. But if it's inelastic, we know that the price elasticity of demand will be less than what value? 1, which means that how is this fraction less than 1? Only if my numerator is less than my denominator, or we see a percentage change in the quantity less than 10 in this example. So if this is the case, my numerator is less than my denominator, we've got an elasticity less than 1. We said we've got inelastic. Not perfectly inelastic, but inelastic demand. Okay. And then we can start. So this was the guy that bought the HIV drug, right? Increase the prices by a bunch. Okay. If we instead start at the other extreme, we said if it's perfectly elastic, very, very responsive, that means that if I see a 0% change in the price, how much are people going to be responding by? Well, even if there's no change in the price, if I'm perfectly elastic, I'll still buy more for whatever reason. Once again, are there truly perfectly elastic? Probably not. But there are things that small percentage change in the price might lead to consumers buying a lot more of that product, right? You could think about this like, this is a weird one, but sometimes I'd use what's in my life it's my point of reference. So I just refinance my house. Really small percent changes in interest rates, or you can think about the price there, essentially led me from going like 0 to 1, led me to being very responsive. I went from buying nothing, no product from the bank, to buying one. That's a huge percentage change in the quantity demand I had for their product, their loan, or their mortgage. So anytime you have like almost no change in the price, even if it's really, really small, but people buy a hell of a lot more of this thing, you're going to end up with a numerator that's much larger than your denominator. Or if you think about the most extreme case, even if the price didn't change, anything over 0 is infinite. So anything that's completely elastic or perfectly elastic, we would say it has an elasticity of infinity. Right? And then the slope, completely horizontal demand, we said was 0. And then, if I had some change in the price and I respond by more than that, so maybe I respond by 20%, well, now my numerator is going to be larger than my denominator. So if I have somewhat elastic demand where people are responding by how much they buy more than the initial price change, I know that that fraction is going to be greater than 1, and we would say that demand is elastic there. And then I think we have the other one, which we never, happens seldom in practice, that we would have exactly unit elastic demand, but we are going to use the idea of unit elastic demand when we talk about revenues next class. So I do want to introduce it now because we will use it kind of later on. If I don't answer that question by the end of class, ask me again. But I've got something that I'm going to use that I will answer that question. You're thinking about things in the right way. Yes. Sorry to once again punt, but I know it's coming, so we'll get there before the end of class. Any other questions about kind of this idea of the different ranges that we're thinking about? So, in fact, we'll transition to that right now. So we get out of here at 12:25. This should give us plenty of time. So this should show up on the home page under module 4 now. Once I publish it, it's also under the quizzes, 4.1 in class quiz 4.1. So you can find it in either location. We didn't have class last week. I'm feeling kind of nice. We'll talk through this one together. Shouldn't be too bad if you're paying attention to what I'm saying. Okay? So we'll start off. Hopefully you'll see, even if I was using these and not working through, I will generally give you questions that I think are kind of a little bit softball questions on these in-class quizzes sometimes. If you have been paying any attention and have a pulse, I think you probably could get this first one right? So if I'm thinking about, if I give you a change in a product, so I'm telling you that there's a change in textbooks of 24%, and as a result, people decrease the amount that they're buying, or the quantity demanded is falling by 15. Well, we've been kind of doing this all class, right? If I'm calculating a price elasticity of demand, that's my percentage change in the quantity demanded. Remember, we said what's in my numerator? That's kind of what comes after this word of elasticity. So the price elasticity of demand, I'm looking at how responsive is the quantity demanded to what? Well, it was the price elasticity. So how responsive is it to price changes? I had the percentage change in price in my denominator. If I simply give you these percentage changes, if I wanted the actual value, you could go ahead and just plug them in and calculate it, right? So if I'm thinking about here, my percentage change in the price is 15%. My percentage change in the quantity demanded is 24. So which of these is larger, the percentage change in the price or the percentage change in the quantity demanded? Price, right? We've got to be able to compare two values and say which one's larger. Here it's price. Where is price? In my numerator or my denominator? So I just wrote it out. Where is it at? It's always in the denominator, right? Whatever is the initial change, whatever we're responding to, so the initial change is in price, and we're saying how responsive is demand. The initial change is in my denominator. What is responding is in my numerator. So here, if that percentage change in price is larger, I know that my fraction is going to be less than 1, which is going to mean demand is inelastic. We said we have these different ranges. And if I forget, like, oh, wait, was less than 1 elastic or was greater than 1? Think about the extremes. If I have a vertical demand curve, what is not changing? The price is changing, but the quantity is staying the same. So that means I'm not responding at all. What's my elasticity there? Well, if the percentage change in quantity is nothing, 0, my elasticity for perfectly inelastic is 0. So the lower values, the values getting closer to 0, are going to be inelastic demand. So less than 1 inelastic, 0 is the most inelastic, greater than 1 elastic, infinite was where we saw it was the most elastic. Okay. Now I didn't add it in as a question here, but if I had a second part of not whether or not it's elastic or inelastic, but did the price increase or decrease here? So knowing something about the demand curve, even though when we calculate the elasticity of demand, we just care about the absolute value. I told you there was a change in the price here. Was it an increase or a decrease in the price? Yeah, how do you know it was an increase? Well, if the quantity demanded went down, what's true about the demand curve? That's telling us the relationship between price and quantity demanded. So as we see higher prices, people will buy less. So if the quantity demanded goes down, that must have meant the price went up. Okay. So I didn't ask that question here, but just kind of instilling, like, we're using things we talked about from module 3 about the demand curve. We could still kind of apply them to the types of problems if we're thinking about things now. Price elasticity of demand, we're still talking about the demand curve. Okay. All right. So the next one, what if I'm changing the price from $20 to $30 for gym membership, so I'm increasing the price. As a result, the number of memberships I sell goes from 120 to 100. So it's decreased, right? How would I find my price elasticity of demand here? Right? So we'd have to use the midpoint method. So once again, I would probably break this down into parts, right? But how do I find a percentage change in my quantity demanded? That's going to be the change divided by the average. So if quantity was going from 120 to 100, what was the change in my quantity demanded? 20. Technically negative. What's the average of those two values? I would simply add them up, divide by 2, or 100 plus 120 divided by 2 should give me 110. I think this is 0.18 repeated, right? Okay. So I've got my numerator. I also need my percentage change in price. How do I find that using the mid? It's the change in price over the average. This one might be a little bit easier for me to do the math in my head. The price went from 20 to 30. So the change in price was 10. What's the average of 20 and 30? We're going to add them up and divide by 2, or, I mean, hopefully at this point, 20 and 30, the average value there is 25. Figure out what this is. It's what? 0.4. Plug in 0.4. 0.18 over 0.4, I think gives me 0.45 repeated. Someone can check my math for me, right? So here's my price elasticity demand. Now I could have went and like written this out in terms of like change over average divided by change over average, plugged everything in, used all the parentheses, entered it into my calculator at one time. To me, it's easier to kind of break it down by pieces here. But whatever you find easiest, like, it's up to you, right? But really, this is going to be kind of really simple mathematics, right? Kind of knowing that to find a percentage change, I'm just going to take that change and divide it by the average of those two values, okay? So if I round this to the second decimal, we had what, 0.45 there. So if I think about this, just to kind of add in some things, you could, like, different questions or think about these concepts. If I had the same setup, it was the same change in price, so it'll end up being the same percentage change. But let's say the quantity went from 120 to 60. Without even calculating the value, does that represent demand being more or less elastic? Will it have a higher price elasticity of demand or a lower price elasticity of demand? So let's just intuitively think through this. If the same percentage change in price led from quantity going from 120 to 100, instead was 120 to 60, was demand being more or less responsive there? More, right? It was going from 120 to 100, now it's going from 120 to 60. That's a larger percentage change, okay? So now my numerator, if it's a larger percentage change in the quantity demanded, but the denominator is the same percentage change in price, also just intuitively, if people are buying way less than they were, they're being more responsive, the elasticity should be higher, right? And I can think through this. Why? The percentage change in price was the same, but 120 to 60 is now going to be a larger percentage change in the quantity demanded. My numerator is larger. My new price elasticity is going to be larger as well. Larger price elasticity of demand, closer to infinity, is going to be more and more elastic. So if instead we see larger percentage changes in the quantity here, we know that that's going to represent demand that is more elastic. Okay? Any questions there? Let's think about question 3. So if I had perfectly elastic demand, that meant, excuse me, that even if the price didn't change, what was happening to the amount people were buying? So perfectly elastic, maybe think about it this way. The smallest price change was leading people to do what? Buy a whole lot less. If it was a price increase, they bought a whole lot. So they're very responsive. So even a really small percent change in the price, which is in my denominator, led to a really large percent change in quantity demand in my numerator. So what's going to be true about my elasticity of demand when it's perfectly elastic? Very responsive. A really large number over a really small number is going to be close to infinity. So my price elasticity of demand is not going to be 0. It's going to be closer to infinity. So I can rule this one out. Now, will my price elasticity of demand be vertical? So if I'm very responsive, if it was vertical, what would that mean? That even when the price changed, people kept buying the same amount? That would actually be when they were perfectly inelastic. So if they're perfectly elastic, I won't have a vertical demand curve. I'm going to have a horizontal demand curve. So it's not vertical, it's horizontal. Now, if I have a horizontal demand curve, what's going to be true about my slope? 0. That's going to be the one that is true. Also, if it's pretty elastic, hopefully at this point, this one's easy. Does that mean it's very responsive or unresponsive? We said elasticity, it's synonymous with the word responsive. So if I have perfectly elastic demand, it's out as well. Okay. So this is the only one that made sense for us, right? Was he had a slope of 0. So hopefully, I'll give you the answer to the last one just because I have the time set to be here in 2 minutes, and I know I'm going to take a little bit more time. So I think greater proportion should be the correct answer for that last one. So make sure you're getting that submitted here in the next minute and a half. I think I've got it set to be 12:10. We've kind of covered the first 3. We'll now talk about this 4th one. I just want to give you the answer so you can get it submitted before that time runs out. Okay? Any questions on getting that submitted before I continue on with question 4? We're good? No Wi-Fi issues or anything? Perfect. Okay. All right. So this last question, I'm going to lead us a little bit into this question and what we'll kind of finish class with into next class. But it's going to be important because I'm not going to necessarily reiterate it in class on Thursday. We're going to kind of like have this so that we can kind of jump right back into on Thursday's class. So what's going to make demand more or less elastic? We haven't talked about these things, but I want you to try to intuitively be able to describe them to me before I just tell them, because I know what the answer, I know what it is. So for me to just tell you, I can give you good examples, but a lot of times, not that you guys care about this, but like to help people learn something, it's more effective if you can get them lead them to the answer through their own intuition and then provide them with the examples as opposed to the reverse, right? So I try to do that as much as I can in a class of 300. So if I'm thinking about what is going to make demand more elastic, so let's remember, this means more responsive, right? Remind me to say something in the class. So if I'm looking at something that's more responsive, right? Let's just kind of reason through some of these. So I'm going to start with this one that's fewer substitutes, okay? So if I go up to Ruoff, the concert venue, it's up in like Indianapolis, and they're selling 2 beers. I mean, this is kind of extreme to make the product. Not that any of you are buying beers there, right? Yet, but so if I've got 2 I can buy, and all of a sudden they increase the price of 1. Well, what do I have available to me? A substitute. What am I going to do? If they increase the price of one of those, if they're like Miller and Bud, like just cheap beer, what am I going to do? I'm going to buy the other one, right? So if I have available substitutes, when they change the price of this good, I'm going to be very responsive to that price change. I've got an available substitute right there. Now, if I'm at that concert venue and they only have one type of beer that I can buy, well, if they increase the price, what am I going to do if I want a beer? I mean, I guess maybe I could try to bum one from some stranger and not know what the hell's in it. But right, if I'm buying it from them, I don't have any substitutes. If you decrease the amount of substitutes I have, that same price increase, I might still buy that beer from them. I'm not going to be as responsive because I don't have things I can substitute away towards, right? If you think about anything that has like a lot of available substitutes, as you add in more substitutes, people become more and more responsive to those price changes. I can't remember now if I'm mixing up this section with the last one, but I'm thinking about automobiles. Why do people get so, people will spend $40,000, $50,000 on a car and they'll be upset about like a $500 rebate for this, or like I said, they're haggling with the car salesman over a couple hundred or $1,000. That's such a small percent of the price. Why? Because they know they have so many other types of cars. There's so many other substitutes. They can find something that's pretty similar to that car, and it's highly competitive. So if you give people more substitutes, they're going to be really sensitive to price changes, right? So that's just one of the attributes that's going to impact elasticity. The more substitutes we have, the more elastic we'll be for those products. Because if you change the price, I'll just go buy one of the other substitutes, right? If you think about, we'll do this one because they're kind of closely related. So if I use this idea, I can tie it to time, and I'll kind of give you some other examples. So let's say, I don't know, so I'll give you an example of something where there are a lot of substitutes. So maybe like if you're thinking about housing decisions for next year, and right now you've got a decent amount of time to kind of hunt around for a good deal, find the apartment you like, find a living situation that you like. So what are you going to do? You're going to look at you're going to be really sensitive to all the prices you see out there. Oh, this is kind of expensive. I'm going to look at this other apartment complex. If you get to next year and it's July and classes start in August, you don't have a lot of time, right? What do you also, because you have less time, you now can't find as many other substitutes. The less time you have, I'm kind of stuck now. I got to pay whatever the apartments that are left out there are charging, right? If I want a place to live, I need a place to live within the next month, right? Whereas if I start now, I've got the next, 11, whatever months to kind of shop around for a good deal, be a lot more sensitive to those price changes. So anytime people have less time, I can't be as responsive. I can't find as many substitutes. If we have fewer substitutes, we said that makes demand more inelastic. So less time would result in fewer substitutes. That would also make my demand for a product less elastic. Okay. Now, the one that's going to be true, the greater proportion of someone's income. So I'll use the reverse of that to make the point. So, just to first, if you're spending a lot of, like, let's say you're thinking about buying a house or a car, and it's a large amount of your current income, are you gonna care about that decision more or less? Like a lot. People like I said, people will spend a year looking for the perfect house, right? People, if it's a large part of your income, you're really going to make sure you're getting a good deal. You're going to be very sensitive to how much you're paying for that product. So what are you going to be if it's a larger portion of your income? You're going to be very elastic, responsive to price changes. The opposite, I always think, is easier to think about. If I go to the gas station today and I don't know, I need some gum to chew. If I walk in there and a pack of gum is $1, how many packs am I going to buy? One. I don't stockpile gum in my car. If it's hot like today, it's not going to be any good tomorrow anyways. If it's $2 and I want a pack of gum and I go in there, how many do you think I'm going to buy? So the price changed. How much did I buy? The same amount. So was I responsive to that price change? No. Why? Because it's $1. It's a very small proportion of my income, right? Now, if it's something that I buy routinely every single day, like let's say I buy a pack of gum every single day. Well, now I'm going to probably try to really find like what gas station has the cheapest pack of gum, and I might be a lot more sensitive because I'm spending over the course of the year a much larger proportion. But if it's just a one-off, I don't usually buy a pack of gum and I'm just going to buy it. It's such a small proportion of my income, I'm not going to be as sensitive to price changes. Okay? So that's why a smaller proportion of my income, if I don't care about the price, I'm not responsive, I'll be more inelastic. Whereas if it's a greater proportion of my income, I'm really going to care about getting a good deal. You can think about it that way. I'm going to be very responsive or elastic. Okay? Now, the last one that'll kind of lead us into some stuff we'll talk about next class is if we're looking at a product that has a relatively low price, well, it must be, in this case, it's not more elastic, it's less elastic. But why? So we'll think about some things from the demand curve. So if I'm looking at a demand curve, okay, and I switch this over correctly. If I'm looking here, and let's say I'm looking at the same $1 decrease in price. Well, at the higher point of this demand curve, what's true about my prices up here? Prices are going to be relatively high. So a $1 change, what's going to be true about my percentage change in price? It's going to be relatively, if prices are high, a $1 change is going to be a small percentage change, right? Now, if I'm going from like 1 to 2 changes in quantity on this portion of the demand curve, even a change of 1 is going to be what in terms of a percentage change in my quantity demanded? So going up by 1, if it starts at 1, is going to be a relatively large or big change in the quantity demanded. So what's going to be true about my elasticity of demand for this portion of the demand curve? Well, my numerator is going to be relatively large. My denominator, we said, is going to be relatively small. So this is going to be what happens in my elasticity of demand? It's pretty large, right? The numerator is large, denominator is small. I'm going to end up with an elasticity of demand that is high. The higher my elasticity of demand, we would say demand is more. So the higher our elasticity, if elasticity is measuring responsiveness, higher elasticity means they're being more responsive to price changes. Okay? So initially, at very high prices, demand will start out as very high. If the price elasticity of demand is high, that means people are very elastic. Now, if prices of a good are relatively low, and there's different ways to think about this, I'll explain it this way first. Now, if I lower the price by $1, what's true about my percentage change in the price? It's going to be relatively high. If prices are low, now my percentage change in the price is high. When I have a lot of a product, going up by 1 more unit is now going to be a relatively low percentage change in the quantity demanded. So what's going to be true about my elasticity of demand? If my numerator is relatively low or small, my denominator is relatively high or large, it's more likely that this is going to be closer to 0 or lower. Right? So when I'm looking at lower prices, or I'm at the lower part of the demand curve, our elasticity measures are going to be smaller, closer to 0, which means demand is going to be more inelastic, not as responsive. Whereas up here, we had relatively high price elasticity of demand. Demand at the top part of our, the price elasticity of demand at the top part of our demand curve was going to be relatively elastic. So where we're at on the demand curve changes what the elasticity measure is that we calculate. So to your point earlier, where is the unit elastic point? Here we're at the elastic portion. Here it's becoming more and more inelastic. At some point, what's going to happen? It has to switch over. The point at which it switches over is going to be where it's unit elastic. And then we'll talk about how that corresponds to different revenue values next class. But this is going to be kind of that last possible option in that in-class quiz question. Okay? So before I let you guys get out of here, so we've got those questions. We'll kind of revisit these determinants of demand. I'll show you some examples. We'll then kind of jump to the fact that we have different elasticity measures at different portions of the demand curve. Also, you know, what do you think is going to cause me to be more or less friendly? What is my responsiveness going to be in the future? If I see larger percentages of people leave, even as I'm trying to tell you something at the end of class or right after giving the in-class quiz, do you think my kindness is going to be more or less responsive to that moving forward? Less, yes. I'll give you guys a one-off today. I mean, I get you guys have things to do. I'm talking to the wrong people because all of you are still here. But I'm also trying to get you guys prepared for what you're eventually going to be in the business world. If you leave presentations early, what do you think that's going to do to any connection you had in that room? Do you think that's going to build a really good network for yourself? No. So if I see people leaving and all of a sudden, oh, I need a letter of recommendation. I recognize a face or a person that left. What do you think can I have the most glowing if I'm going to be honest? Well, no, if I see you leaving the class, I mean, even if you understand the material, it's great that you're smart, but like, we've got to start to learn some decorum. I wouldn't care as much, I guess, if you guys weren't business majors, but like, that's a huge part of the things that you're going, like, as much as maybe you think it's frivolous, like acting in a way that is professional is going to benefit you right or wrongly. It's the way that the business world works. So that's why I'm harping on it. Once again, talking to the wrong group of people here, but it's in the recording. So maybe if someone goes back and listens, they'll feel a little bit bad about taking off early. All right. So I'll see you guys on Thursday. If you want to meet tomorrow to my office hours or any other time, send me an email. It'll have to be virtual. Other than that, enjoy the nice weather. I will see you Thursday.
For review.
Yep.
Should we do like unit by unit? Can you post like more questions for review or?